Okay, super quickly. Also, this topic aligns well with what we have just discussed. So, like, what I'm going to talk about is storage mediums and SLAs that we think we want to provide to the end clients. The reason why I think it's important to like talk about this is because we assume that everyone is going to use hard drives forever. That's not the case. And like, if you want to really absorb all the storage that exists on the planet, we need to have very different storage mediums. And with that, probably we also need additional cryptography that is going to allow us to get there. So super quickly, I've been mining since 2013. Formally, I'm probably the first miner on Filecoin. So I minted this address with Igor, back in the days. Been doing a bunch of stuff in the Ethereum ecosystem, building smart contract tooling, led smart contracts for Cardano, and joined the PL team working on Filecoin since 2021. So let's get directly in the topic. So storage mediums are very sparse. So like we know like of a few ones that are kind of popular, but there are like probably 20 storage mediums. You have like storage mediums based on like some biological ways of like storing stuff, DNA storage mediums, and so on. Of course, those are not as popular because like it's hard to actually use them. But one that is very popular that no one is talking about is actually tape. And to some degree, like we are kind of not really competing with tape, but we are kind of close to competing with tape. So it's very important to understand that like those exist and really plan forward for actually supporting them on the protocol. Now, I'm going to go deeper into how we should probably try to think and reason about different storage mediums when it comes to the incentives on the network. But let's go first in the different storage mediums that we know that exist and that we know that at some point we want to have on the network. So if you look into tape, tape is probably the highest density medium that is to a particular degree practical. It is super low cost. Like basically you can buy a cassette that has like 60 terabytes for $100 or something like that. It is very slow though. So for high val it might work well. But actually retrieving something from those cassettes is very, very slow. It is also very expensive as well because like those cassettes would need to go into like a particular device that allows you to read from those cassettes. And moving physically something to actually retrieve something is like not ideal. Now, although that allows like very, very affordable storage, mainly because of the cost and the low energy that tape uses. So yeah, on the other hand, like figuring out how to actually onboard tape to Filecoin is very challenging because we would need to change proof of replication and we would need to have like proofs that are being sent maybe once a month, maybe optimistic proofs and things like that. But it is worth like thinking about tape because it's pretty good for a very large use case, which is archival, which we are kind of competing in right now.
As someone who was a support engineer supporting Google, I can promise you, even though Google will never admit to it, every byte of data at Google is archived on LTO tape.
Yeah, the next one is hard drives. Hard drives is what we think is the way to go right now. Although hard drives are kind of a risky medium if you think about like the market trends. So and we will see later like how hard drives compare to tape and SSDs. But hard drives are probably the best fit now, but they have like many things that are not super nice. So of course hard drives are relatively low cost, relatively because yeah, they are low cost if you need to retrieve things frequently. So for the use of Filecoin, they are really very well balanced. They are affordable in the context of retrieval. So like if you need to read data from those drives, you're going to be able to read that relatively quickly. So it takes a few milliseconds to actually read the things from the drives. But the issue is that they are very energy intensive. So they use a lot of energy, especially on Filecoin because we currently don't let users turn off the drives, which is something that like most of the storage providers in the context of Web2 do. The reason for that is winning post, which kind of asks for random things all the time from the drives. And probably like a topic would be also figuring out like all the different things that we can do on the cryptography side in order to allow storage providers to get better and better in terms of efficiency. Then if we go into NAND, NAND is probably the thing that is getting like most of the innovation right now. Like the density is skyrocketing. Like in one thing here, like you can fit 60 terabytes, and those 60 terabytes are super fast. So ultimately, right now, like the problem is not in the SSDs. The problem is that CPUs don't have enough PCI Express lanes to actually read from those SSDs. This is how fast they are. But the issue with SSDs is that, of course, like they are very expensive. Now, in the context of price per terabyte, like they are getting closer to drives. And maybe if you take into account the OpEx, because now you don't actually need to, you can actually turn off drives fast enough to turn them on back again for winning posts. Those might get more competitive over time, but right now, like they're very, very expensive.
Are they just priced higher? Or are they also more costly to make? Like I'm just looking at like how hard it is to manufacture a NAND versus an SSD.
They're significantly more expensive to make because the yields and the mapping and the manufacturing process. So your NAND flash is no different than making a CPU, and it's typically 4 nanometers, I believe. So the yields coming out of the wafer process, there's a sorting and testing and a burn-in cycle and whatnot. Yeah. Whereas an HDD, that is a sputtered, at an atomic level, it's sputtered across the platter, and then there's a 2-week manufacturing process for each HDD, where you tune in the bit density that you can achieve, back it off 10%, and that becomes a shipping zone. On a typical disk drive, there may be 20 recording zones across one linear surface, but they can optimize the process. And now that they've got waterfall drives coming on, you won't be buying the 18 terabyte drive. You'll be buying something between 16 and 24 terabytes because they don't have to bin and sort things, which reduces their sorting costs, whatnot, makes it much more difficult for the file system guys. But the fact is, it's a sputtering process, and you can almost generate yield from anything that comes from the output of the HDD line. That's not true from a wafer fab process. And the investment to get to the next density is actually a die shrink on the NVMe, which you've got $1 billion factory you have to pay for before you make the first dollar.
Got it. Okay, thanks. That's helpful.
Yep. Of course, retrieval is super fast, and it's also very good for very small files. And of course, that's why NVMEs are being used for most of the database workloads today. But yeah, like they are not ideal for Filecoin right now. Now, if we compare them, so on one side we have like tapes, which would actually be perfect for like many of the things that we need on Filecoin right now. But because of like the way that the Filecoin network was architected, we are really not able to use them today. Then we have drives, which are kind of more expensive in terms of capex, but also like it's much more efficient to retrieve particular pieces of data, but they use a lot of energy. And that kind of increases the OpEx of running a drive, which also increases the OpEx of the network. So if you think about how much does it cost to run Filecoin, today it's around $3 million a day in block rewards. If we would reduce the OpEx, that could go substantially down. And of course, NAND is not using a lot of energy, but it does require like a big capex investment.
Okay, so tape not suitable for Filecoin today. HDD yes suitable. NAND yes suitable.
Yes, yes. And if you think about how we could potentially improve Filecoin to increase the efficiency of Filecoin as a network, there are two things. So one is probably easier, which is let's figure out how to make winning posts easier for the drives, or at least more predictable, so that the drives could actually be turned off, which would drastically reduce this part here, which is kind of the main issue with the drives today, instead of trying to figure out how to make a window post or winning post for the tape, which is a much harder endeavor. It would require like a very different POREP, and like it would require like a very different incentive structure for the tapes. Because tapes are basically going to use zero energy because they're going to be like on the shelves. But no one is expecting you to actually read from those tapes. But figuring out how to make drives better suited for what we are doing today is probably the best thing that we can do for the least effort. So if you look at the trends, And this is why it's important to keep in mind like all the other mediums. Actually, we have flash and SSDs that are exponentially going up, but we have drives that are going down super fast. Tape is kind of constant, maybe even growing a bit. So ignoring tape completely would probably be a mistake, but figuring out how to either make drives like be in a better shape, or like figuring out how to make SSDs more dense and with that more efficient would be probably the two things that we want to pay attention on.
Do you know like a cost decay curve for, I mean, maybe you know, but like, you know, today they're expensive. You said $1 billion factory before you can like do anything. Do you know like the cost drop of that? Like, are there projections around that? Like,
As soon as the push to increase the density levels off a little bit, and I suspect that will happen as U.S. manufacturing comes online and doesn't have the churn and burn. Most of the NAND flash and related stuff starts out on one production line at TSMC. So they've had a de facto monopoly on that pinch point that ups the next capacity point and pushes the next technology advance. When that becomes a little more distributed in the United States and there becomes a little bit more hesitancy to increase the bit density of NAND flash and it becomes more commodity, then the price is going to just nosedive. Then HD's in real deep trouble.
Yeah, and on that, it's also super interesting.
we're talking about like years for this. Like, if you had to like, you know, when are we hitting that inflection point? Because like right now it looks like HDD might be the bet that you would bet on today for Filecoin, right? Like, but maybe 2 years from now.
We're at least 24 to 36 months out from any of those production facilities reaching volume, and will be at least 12 to 18 months out after you get volume production, where there's a hesitancy to retool for the next latest, greatest fad. So I'm guessing 4 years out before we give up on the technology advancement cycle and turn it back into a commodity. You know, cars have been stable since Henry Ford did the assembly line. We are approaching that point where the NAND flash storage business is going to turn into a Henry Ford style assembly line rather than building Formula One race cars.
Yeah. Also on that point, like it's very interesting to think about what's happening in the tape market, because tape can get much better, but because very few companies have like a monopoly, they are keeping it just a bit better than hard drives, and that's a bit. And I think Filecoin, if it had like an incentive structure to enable tape to be on board, that incentive structure would actually unblock that monopoly and would allow like those organizations to get better and better and actually manage that tape themselves, which is not the case today. So basically they're blocking humanity because hard drives are getting better enough. Okay, cool. So now, in order to understand where we are today, like let's just look at different storage tiers that exist today. So like on one side we have Backblaze, we have Wasabi somewhere here, then we have like very fast retrieval, and then we have like the typical cloud providers with their monopolies on storage. And the price difference is very big. And if we want to focus on something as a network, we really need to understand where we are. And instead of looking at it from this high-level perspective, I would focus on one particular cloud and really look at their different products and try to figure out where we are as a network. So if you look at the Google Cloud, of course, they have the standard tier. That's $20 per terabyte per month. Retrieval is relatively affordable. It's quick as well. And of course, you can store in buckets for no minimum duration. So like you can store something for a few milliseconds and remove it if you would like. But of course, the storage is super, super expensive. Then you have nearline, and then you have cold line. So nearline is kind of available, but it takes you 3 seconds to actually read it, and it does cost more to actually retrieve data from nearline. And the minimum duration that you can actually have is 30 days. And then you have cold line, which is substantially cheaper than nearline, but it also costs more to actually retrieve the data, and the minimum duration that you can commit to is 90 days. Now, the last one is archival, which is probably tape. So, of course, Google is not really talking about what they do in the background, but this is likely tape because it does cost a lot to actually retrieve. and the minimum duration is 1 year. And the reason why the minimum duration is 1 year is because you physically need to go take the tape and actually write to that tape and then archive that tape and like not touch it for a while. Now, the issue is that like in the Filecoin network, I have the feeling that we are just focusing on the extremes. We are really not focusing on where Filecoin is really today. So we are talking either about retrieval and having a CDN style workload, or we are talking about archival. And of course, we don't want to compete in archival because we are competing with a much more expensive medium that has like better characteristics with the tape. So like you don't want to compete with drives and tapes, even though we have block rewards that are kind of subsidizing a lot of that today. But that would be just a race to the bottom, and of course tape would win. What we want to compete on is this. And this is likely hard drives. Of course, Google doesn't want to share that. I probably think I could find it from like the Google. Yeah, it's not obvious, but this is also a new market because this was released. Nearline was first released maybe 6-7 years ago, and they were very like secretive on what they actually do. But what likely is happening here is that they have drives, but they have like ways of like either turning off those drives or really slowing down those drives. And today, if you try to actually buy drives that are able to do that, you can't. The only ones that can actually get to the firmware that has like that capability is the big cloud providers. So figuring out as a network how to actually first compete in this space, and then how to actually also like have the hardware that enables us to be as competitive with the cloud providers is super important. Now, I want to wrap up with more questions and think a bit more on it. At some point, I'm going to try to like propose some changes on the cryptography side just to allow us to be in this particular bucket, which is really not possible today. And the reason why it's not possible is that in order to get rewards on the Filecoin protocol, you are sending two kinds of proofs. One proof is window post, which is basically the snark every 24 hours, and everyone knows about that. But there is another thing, which is called winning post, which is basically kind of like asking very frequently with a very short challenge duration for a particular piece of information. And if you don't get that back, first, you don't get the block rewards, but secondly, you can also get penalized. And that might be too aggressive. On the other hand, what we could do is we could combine a different balance where we will have maybe more frequent window posts, but less of an aggressive winning post, which would allow us to turn off drives once a day, and then have like 2 periods when we are actually sending the proofs to the network. And yeah, when we
you probably don't know this, but if you go back one slide, like I wonder like how thick or thin the margins are for a nearline and cold line. You know what, like how hard you'd have to go in there before they'll just say, yeah, fuck it, like we'll just half the price.
Actually, I think right now, as a network, we are on nearline because we are not yet able to turn off the drives.
But like Google's nearline margin is probably still 20%, and on Filecoin it might be 5. You know, so they have like more wiggle room to like drop prices and like actually engage in some kind of competitive.
So what we could assume is that Google didn't want to cannibalize a particular search tier with a new search tier because they invented it. So probably they are trying to keep the same margins. But maybe there are like more people that know about this.
But there are so many things that we can do to wrench out cost in this that we can do that Google can't do. I can go on with you one-on-one, but there is so much low-hanging fruit here.
I think one thing that's worth pointing out is that a lot of the ways that storage providers make most of their money is with egress and egress payments. At least in our case, at Storage. Storage node providers cover their costs with at-rest payments, but they make money from egress. Egress is very cheap. It's very easy to get some bulk discount deal, and then you earn money from the egress. And so I think maybe a missing piece here. I'm actually not convinced that nearline is different technology than standard. I think they're doing financial tricks with the minimum duration, and Wasabi famously, they limit the amount of egress that you're allowed to do in a financial sense. Their technology is like whatever, but then they make a ton of money if you egress more than 1x the data over a period of time, because there's a lot of charges for egress. So I think maybe part of the picture here in terms of making this economical for storage providers is actually maybe to think, it sort of goes back to some of the retrieval conversations that are going on. I don't know that it's possible to solve the entire economic picture here without having a way to pay for retrieval, if that makes sense. And so that might be... the numbers here, I think that the values for this third column are actually really important to making the whole picture work.
Yeah, absolutely. On the other hand, if you're thinking about an open network where you have a particular resource that is being provided, sure, you'll have an entity like Wasabi trying to actually use particular strategies to increase their revenue. But it's important to focus on the absolute numbers and try to reduce the costs for the network overall. And of course, this is going to be most of the revenues if there is a lot of retrieval. But it's important to understand that even retrieval today is hard, and it does require some resource, and it can be either retrieval of the data that someone is storing, but it can also be retrieval of a particular piece of data that no one else has. And that would actually create an open market for data, and that is very hard to estimate here. But even on the storage side, you can be very, very competitive without the retrieval.
And in the context of storage and the Filecoin mine meld, if we stay cold line on the Filecoin network and we are able to minimize the erasure coding footprint required to maintain a storage nearline network that is the presentation layer for that makes up that higher revenue tier, then even when an erasure slice goes offline, we have the cold line to restore that. The funding of that becomes the penalty of restoring the missing nearline shard, and so your erasure coding footprint becomes a much more wider, and while you still have the resiliency of the backing thing. So all of a sudden, the plug-in tiering, if we mind meld these two distributed concepts and they can be co-hosted on the same storage nodes, all of a sudden we can accomplish that and actually do it, because the difference between nearline and standard is latency. That's about it. But when you get to the next level, being able to mind meld the best attributes of our cold line archival storage now with the nearline that storage is offering, but making storage more storage efficient by not having the level of erasure coding to survive a flaky network or flaky service providers, because you've got to back and store the cold line, and put the penalty of the lost shard on use that to fund the replacement of that shard from the cold line representation of it, and then you've got win-win.
Yeah, and you'll probably have people that want to do arbitrage on top of all of that, and we'll see financial tools that allow people to gamble. So,
but it is a good point. Even retrieval put real numbers behind it, right? I think that's an interesting exercise, and there's probably different ways to do it. But I think you also alluded to you can do some magic on the accounting side if you have a 30-day bill that you're paying, and you have different capital efficiencies that you can achieve. So I think it's interesting. There's probably some dollar number that you can attach to minimal duration days, just in terms of what you can squeeze out there in terms of whatever charging interest or all these sorts of things, or just having more efficient cash flow or something that also results in some kind of competitiveness.
Yeah, it's interesting because those will probably come from smart contracts on top of the base storage, and people actually playing financial games again, and then having a based layer of storage at a commoditized price. Okay, cool. So, yeah, the last thing will be to really figure out how to onboard other mediums like tape. But that's a more difficult thing, and it would probably require like a different set of block rewards for a different medium, because you don't want to have like hard drives competing with tape. So you'll have like a different block reward that only goes for a particular POREP. So you would have like POREP for hard drives, a different POREP for tape, maybe a different POREP for other stuff, and with that like different tiers of block rewards for each. But anyways, I'm gonna wrap it up here, and if there are any questions, we'll cover questions.